The other approach we'll discuss is called an adjacency list. So I actually changed these nodes, the vertices, to be numeric, and you'll see why in just a second. It's easier to show how you could store this. So instead of A and B, C, D, so on, we have 0, 1, 2, 3, 4, 5. So the way that this works is we use an array or a list to store the edges. So if we wanted to figure out what edges, what connections there were between 3 and its other nodes, the other vertices, we would go to index 3 of our array, 0, 1, 2, 3 right here, and then there's a list there that contains the connection. So there's a connection between 3 and 2 and 3 and 4. As you can see here, those are the edges. If we wanted to know, is there an edge between 5 and 1? Well, we would either look at index 1 and look for 5, it's not there, or we'd look at index 5 and look for 1. It's also not there. And this is an undirected graph, so we have things stored both ways. For example, 0 has an edge to 1, 1 has an edge to 0. So this is another way of storing it. However, if we're talking about letters, if we're going back to this, where we have A, B, C, D, E, F, and letters is arbitrary, but let's say it's a name, a string, or something else that isn't just a number, right? This one hinges on using the positions of an array. To find the connections, the edges from 0, we go to the 0th item. And that works, but what if our nodes aren't numeric? What if they're not in order like this? What if they're strings? Or what if there's huge gaps between the numbers? So we don't want to just use an array. What else could we do? Well, we could use a hash table, use a key value pair data structure. So a dictionary, a JavaScript object, a map, there's many ways of doing this depending on the language, but here's the exact same information where we store for a given key, instead of a key being a number like 0 in an array, it's now in a hash table or a hash map. To look at the connections, the edges from A, we look up A inside of this structure, and then we look at the list and we see, all right, there's something from A to B and A to F. As you can see here, A to B, A to F. Same thing, let's do E. So we'd ask for E from this hash map, and we get this. So that tells us there's a connection between E and D and E and F. Okay, so this is an adjacency list.